Everyone. In this session of CCNA series, I will discuss configuration management in automation. Traditionally, network devices such as routers, switches, and firewalls are typically configured individually using device CLI or web-based GUI. The configuration are stored locally on each device in NVRAM such as flash memory and are loaded into the memory when the device boots up. As the network grows and gets more complex, traditional configuration management in network encounters many challenges. Some of these challenges include manual configuration, wherein the configuration is done manually on each device, which is time consuming and error prone. Manual configuration can lead to human errors, and human errors can lead to network outages or security vulnerabilities. Another challenge we have is configuration drift. Over time, configuration can deviate from the intended state or baseline configuration. It occurs when your node current configuration drifts away from the baseline configuration over time. This happens due to various reasons, including manual intervention, software updates, and environmental factors. Another challenge is limited visibility. Traditional configuration management tool provides limited visibility into network-wide configuration, making it challenging to troubleshoot issues and ensure consistent policies. Another challenge we have is scalability. As network grows in size and complexity, managing configuration manually becomes increasingly difficult and resource intensive. Another challenge is change management. Tracking and managing configuration changes manually can be challenging, especially in an environment where multiple administrators make changes. All of these challenges can be addressed by implementing automated configuration management tools and practices across the network. Before we go ahead and discuss about the configuration management tools and practices, we need to understand what configuration drift is. And for that, let me explain you with this, this with an analogy. Imagine you have a perfectly organized bookshelf where each book is neatly arranged in alphabetical order. However, over time, as books are borrowed and returned, some are misplaced or put back in the incorrect order. This gradual change from the original organized state to a slightly disorganized state is similar to configuration drift in networking. This analogy will help you understand what actually configuration drift is when I explain you about the configuration drift in networking. In a network, devices are initially configured to a specific standard or policy. However, over time, changes are made, like adding new configuration, modifying existing configuration, or not properly updating configuration after network changes. The device's configuration can drift away from the original standard. This drift can lead to inconsistencies across the network, making it challenging to maintain and troubleshoot the network effectively. So, this is the uh, small explanation on configuration drift. Let me go ahead and explain you with this with an example. And for that, let me share one example of two network engineers, Mike and Andrew. Both are working for some enterprise called XYZ. Both are well experienced and very organized. Now, Mike receives a call one day regarding an issue on core switch 1. He logs in into the device, fixes the issue, and solves the problem. by changing some configuration on core switch 1. The same day, Andrew receives a call regarding another issue on core switch 2 regarding a different problem. He logs in and modifies some configuration on core switch 2 or troubleshoots and solves the problem. But due to some urgent tasks followed up after that, they forget to update the resolution and they forget to update each other regarding the changes done. And over time they get busy, this topic never comes up, and neither mentions the changes to each other for months. This explains how configuration drift can occur, an effect in which the configuration drifts away from the intended configuration over the time. This can be controlled by using centralized configuration files and version control, which we'll discuss in the upcoming slides. As you know, the manual configuration model makes great sense for smaller network with one or two router switches with one network engineer managing it. But for large networks with hundreds or thousands of network devices with multiple network engineers could be a challenge. This can be improved by storing uh, backup copies or files of each device's configuration in a central repository. Centralized configuration file refers to the practice of storing in configuration information for network device in single central location. The central repository holds all the configuration files for routers, switches, and other network devices. Now you have the configuration file available on device as well as the central servers. Engineers could change the on-device configuration as well as configuration on central servers. So now the question that comes into mind is, which configuration file is the single source of truth in this model? For example, if the copy of R1 configuration on the device differs from the file on the centralized server, which should be considered as correct? Or if like it depends on the enterprise, if some prefer engineers to change the on-device configuration, or like as well as text files on the server, or some enterprises use the on-device configuration files as the source of truth with the centralized configuration file treated as a backup copies in case the device fails and must be replaced, or some might consider files on the server as the single source of truth about each device configuration. These are the different scenarios company can prefer, but it can again like confuse you guys. But by using centralized file as a source of truth, admin can take advantages of many configuration management tools and manage the configuration more easily and with more accuracy. Okay. Now, another important topic is version control. By using centralized management and configuration management tools, uh, use version control software. Version control software or VCS are software tools that help manage changes to files by keeping track of different versions of the files, who made the changes, and when the changes were made. Some common version control systems include Git, Subversion, and Mercurial. These tools allow you to compare the differences between versions of the files. As you can see, I'll show you one sample of comparison between two versions of the configuration file. The upper highlighted lines with a minus sign shows the line that were changed, while the two lower line with a plus sign shows the new version of each line. So this uh, type of tools can compare the configuration and give you the differences. So version control software solves many of the problems and offer several benefits, such as change tracking, which keeps a history of all changes made to the configuration files. And then collaboration, which allows multiple network administrators to work on the same set of configuration files without any conflict. Then we have benefit of auditing. It records configuration changes done by who and when, which can be important for compliance and security purposes. So by using centralized file management and version control together can help streamline the management of network configuration. That's it for this session. I hope this was informative for you. In my next session, I will discuss about configuration monitoring and enforcement and configuration provisioning. Thank you for watching.